Okay, it's recording right now, so we are going to start today's lab. For those of you who can't join us right now, you can come back and watch the video later. The thing is, you have to learn about the syntax and the grammar and how to use MATLAB in general in order to do the assignments for this lab. So let's take a look at the MATLAB itself. So let's take a look at the program. So by now, I suppose that you downloaded the program and installed on your computer. So if possible, let's try to use this program together right now. So at this point, you see a lot of stuff in MATLAB window, but let's take a look at the main things that you have to pay attention to. So the first one, the main window, is right in the middle. It's called a command window, this one. And this is where we are going to put all the commands in. Just think of this as the screen on your calculator. The things that you type on your calculator is the same as command window. We put all the numbers and commands inside this window. And now the next one is the workspace on the right-hand side. This is where we store the variables. Like anything that we work with, the data, anything that we want to store and use it for later, we are going to store it right here at the workspace. If you want to compare this to a calculator, in your calculator, you can put some variable into the memory, like A, B, C. This is the same thing. But in MATLAB, you have so much space. You can store like thousands of data inside this workspace. So it's going to show up right here. But right now it's blank. It means that nothing is in the memory. Okay, because we haven't started yet. And now this one down here, command history. So anything that you type in the command window and you press enter, it's going to get recorded and it's going to show up in the history. And you can use it again at any time. For example, I can put 1, 2, 3 like this, just random stuff. And if I press enter, it's going to go into the command history, something like that. All right, for now, I'm going to erase everything, right, so that it's quite clear to you. Okay, now you know about the windows. On the left-hand side, you don't have to worry about that right now. We can talk about this current folder later, but not at this point. Now, at the top, you do not need to worry about the new script right here. We are going to use these two buttons at the end of the session. Okay. At this point, I want you to take a look at this layout. At some point along the way, your windows might be messy and all over the place. You can go to layout and choose any type of layout you want. For example, if you wanted 2 columns, you can choose that. So we focus on the command window and the current folder, but I'm going to go with the default. Okay. And one more thing that I want to add to this layout, which is not in the default, is this one down here. Oh, command history. As you can see, if I choose default, the command history at the bottom right is gone. So I want that back because I want to see the command that I typed in. So let's go into this layout. With the default, we can't see it. But if we go down and then we choose docked, it's going to show up on the right-hand side. And the command that we typed in shows up right here. So that's it. That's all you need to know when it comes to the interface at this point. Now, there is one more thing that I have to do, but you guys don't. So I'm going to go to Preferences, and I'm going to increase the size of the font so that it's clear to you guys. So I'm going to change it to 18 like this. So I apply, and now I can type anything, and it should be more clear to you guys on the screen. Okay? But you don't have to do this unless you want to. That's it for the interface. Now, let's take a look at the lab sheet. We are going to go through all of these operations and along the way, learn about the commands and syntax. Okay, it looks a lot, but we are going to go category by category. Okay, Now, first of all, I want to talk about some of the most helpful commands that you use in MATLAB. And let's take a look at this. So the first one that I want to show to you is this CLC. This is the command for clear command window, clear screen. For example, if I have 1, 2, 3, 2, 4, 6, and 1, 9, 8, like this, random stuff. And now the window is messy and I want to erase everything. I want a clear screen, blank screen. You just type CLC like this, and everything is gone. Okay, now second command that is useful is clear. As you can see on the workspace, we have something showing up. I'm going to explain why this shows up later, but we have something in the memory and we want to clear it. We want to make it blank. You can put clear all, which means that we want to clear everything in the memory on the workspace. And once you type enter, the workspace will be blank, will be empty. Okay, so CLC for clear screen, clear all for clearing the workspace. And now the next one is help. For example, if you want to know about a certain command in MATLAB and you don't know what that is, you type help and follows with the command that you want to know the information. Help, for example, plot. You want to plot something and you happen to hear this command from someone, but you don't know how to use it. You can use help and you press enter. And you get all the information about plot command inside MATLAB. Now, what about simple command like sine? This sine in MATLAB, sine of some angle, but in MATLAB, if you type help like this, and let's see if we get anything. And it shows that sine not found. It means that in MATLAB, we don't use command sine, but instead we use command sin. This is recommendation from the MATLAB itself. So instead of help sine, we help sin. We are going to get the information about this command sin. So it says that sin x is the sine of x. So you are supposed to put x in some value of angle, and it computes sine for you. Okay, 3 commands that are important: clear screen, CLC, clear workspace, clear all, and help for finding any information about the function you want to know. Okay, all right. Now, what about sorry. And now, what about we start with the lab sheet that we have right here? Let's go through this one by one. And for each one of them, it requires different command. Okay, let's take a look at practice number 1 and take a look at this one. We want to calculate this 2 to the power of 5 divided by that -1. Now in MATLAB, let's take a look at what kind of command we need. So in MATLAB, do you want to find power of something? You use this bracket pointing up, this small one, which is supposed to be the same as in your calculator. So if you want to have 2 to the power of 5, you just put it right here. And then at this point, let's try to press enter. Before you press enter, I want you to take a look at this. Workspace is empty. Nothing in workspace. And now we have this command, and then we press enter. And we know 2 to the power of 5 is 32. And then all of a sudden, in the workspace, we have this variable ands. So this is one thing I need to tell you. Every time you calculate something, maybe 3 plus 4, like this, MATLAB is going to assign the result of that calculation to a default variable ands. And right now, ands takes 7. from the result of that calculation automatically. And now, if you calculate again, 2 to the power of 5, it's going to overwrite the old ends, and ends becomes 32. So this is something you should know. Why this shows up. It's automatic. It's default. Okay. Now, at this point, we know 2 to the power of 5, we can use this command. Now, what if we want to have 2 to the power of minus 5? In that case, you can have minus 5 right here. So you don't have to worry about the confusion with the minus sign right here. MATLAB understands minus 5 right here as the power. So we have 1 over 32, which is this number. But the good thing about MATLAB is that it's quite flexible. If you are not happy with this kind of syntax, you can always put parentheses over this, and the result is the same, 0.0312. So in MATLAB, you can always add extra parentheses, and it has no problems. But don't forget that parentheses has to come in pairs, not just one side, okay? And now we can see that ands, the default variable, takes the new value automatically, okay? Now, there is something I need to warn you, okay? What about 2 to the power of 5? And then I put minus 5 right away. Now, this can become a question, whether this is equal to 32 minus 5 or 2 to the power of 0. So as you can see here, what we see right here can be interpreted as this, 2 to the power of 5 minus 5, 32 minus 5, 27. Or it can be interpreted as 2 to the power of 5 minus 5 bunched together in the power. In this case, we get 1. So what if we take this parenthesis out? What's going to happen? And now let's take a look. So we can see that without the parenthesis, the power only takes this number as the power. So minus 5 comes later. But if you are not sure, you can always put this parenthesis to guarantee that you get what you want. Okay, but this is to test you guys that it's going to take just this 5 as the power, and now minus 5 comes later. So you have to be aware of this kind of grammar inside MATLAB. Okay, now I think at this point it's too messy, so I'm going to clear screen with CLC, and I want to clear the variable and the default one to be gone. Clear all. And now it's clean. Okay, at this point, we can do the first one. It's 2 to the power of 5, straightforward. And now divided by. So for the division, I'm going to group this one together to prevent confusion. Okay, so divided by, and we get this term, 2 to the power of 5 minus 1. Okay, so this one is supposed to be together. So with the parentheses I put in, it becomes clearer about what's going on. Without this, it can be ambiguous. We don't know whether 5 divided by this thing is at the top of the power or this division is at the bottom. But if we put parentheses, it's clear by itself. So I like it this way. Now, we tested this already. That minus 1 comes later, so we don't have to put anything right here. But if you want to make it sure, you can put another set of parentheses to group this together like that, so that we know it's 2 to the power of 5 and then minus 1. But since we know the grammar on this already, so I'm going to take it out to reduce the redundancy of the syntax. And now this is 32 divided by 31. So it should be 1 point something. Okay, and now it's going to get assigned to default variable, and again, it shows up again. Okay, so we found the answer for the first chunk in the first example. And now they ask us to compare it to another expression, which is the same value, but arranged differently. So let's try to compute this one at the back. Let's take a look at this one. This one, let's follow this directly. Let's see if it's the same as that. Okay. Now, if you work on this mathematically, it's the same expression. All right. So let's try this one in MATLAB. Let's check it out. So for this one, I'm going to work from the inside. I have 1 minus 1 over 2 to the power of 5. So 2 to the power of 5 like this. Okay. And now we can see that we have inverse at the top. So I'm going to group all of this together like this. Oh, by the way, if what I am talking right now is easy for you guys, you can just skip and work on your own. Okay. So this is up to your level of MATLAB. But I'm going to have to go step by step because some of you do not know the syntax. Okay, so we have 1 minus 1 over 2 to the power of 5, and then we have the power of minus 1. At this point, we can leave it like this because we know the power is going to take minus 1. Like that. Same number, 1.03. Or you can put an extra set of parentheses right here. Same thing. So as long as you understand the rules, then you can use many variations of the syntax. All right, so that's it for exercise 1. And now we are going to move on to exercise 2. And for this one, we have square root, and this is going to be a command because when it comes to a square root, we don't have the sign to use in MATLAB. It has to be a command. And that command is sqrt. Okay, not the same as calculator. Calculator, you have the square root sign. But for this one, it's this one, square root sqrt. Now, if you want to know the information about this function, you can always type help sqrt, and it shows the information of this. So it says that if you want to find the square root of something, just use this function. Okay, now let's take a look at this example 2. You can go ahead before me if you want to, and let's compare the answer at the end. But for those of you who want to follow along with me, you can do that. Now, this one, so I'm going to work on this all at once. So when it comes to this, the way I work, okay, clear screen. So 3 at the front, and now times something a lot inside. So it's going to be this. I'm going to leave it like this. When it comes to multiplication, don't forget to have this, because sometimes you look at the lab sheet like this, and you have something inside. You have this multiplication without the sign, and then you use the same thing in MATLAB. It's going to complain to you. So I'm going to show you what happens. All right, so if this 3 times 4, you get 12. It's obvious. But if you put 3 and then 4 like this, it's going to complain. I don't understand what this is. It says that invalid expression. And the good thing about MATLAB is that it gives you the hint. It shows that something is not right at this location. And it even gives you the suggestion for the right one. Did you mean 3 times 4? So you can choose to use the suggestion, or you can just ignore it. Up to you. Okay, so for this one, we can clear again. So let's do this one really quickly. 3 times something inside. I'm going to leave it like this. And now I work the inside. The first chunk at the front is square root 5 minus 1. This one right here. So I'm going to construct that. So this is RT, and I want square root 5. That's it, square root 5. And now minus 1. All right, and now this whole thing becomes numerator at the top of the fraction. And now divided by, okay, I have to switch back and forth. This one, same term with the square at the end. So let's have that. Now, at this point, I am too lazy to type again. I'm going to copy this and put this down here. This is a good thing about MATLAB. You can always copy and paste. On calculator, you have to type again. All right, and then down here, we have the square. There you go, done with the front chunk, the front fraction. And now we have minus 1 at the end, which you can choose to put it right away like this, because we know this is going to be separated by the grammar. But if you are not happy, if you are not, if you are confused with the whole thing, so you can always put extra parentheses like this to group the fraction together like this, and then minus 1 at the end outside. Okay, and I'm going to clean it up like this. And there you go. The whole thing that we want to compute in one line. And we have minus 0.5729. And if you got it, if you get it correctly, it should be the same as what I have. And now it gets overwritten over this ands again. Okay. Now, how are you guys doing? How is the pace? Is that okay? Hello?
All right, sir. It was okay.
Still okay? All right, you can always come back, but I have to give you the information about the grammar of MATLAB. It's programming, it's a language. It's impossible to use it without understanding the syntax and the rules. Okay, so that is number 2. Okay, now let's take a look at this. Now we are done with number 2. We still have 8 more to go with this part. Now let's take a look at this one. This one, we are supposed to find the area of a circle with the radius of this. Okay, so in the end, it's going to be pi r squared. But let's they want us to assign this radius to some value. Okay, so pi to the power of 1/3 plus 1. So let's calculate this. Okay, now back to this. Okay, now we need pi. Now let's take a look at what we need in order to have this pi value in MATLAB. And it turns out to be this command, just pi. Okay, so this is default variable inside the MATLAB. It has its own value by itself. So if you want to use pi, just type pi. Let me check whether I can find the information about this one. Help pi. And it shows you that this one, pi, equal to 3.1415. Okay, so this means that it's in radian. Okay, always in radian. Okay, so that is pi. And the value that we need is pi to the power of 1/3. Now, if you put it like this is wrong, because pi is going to take the power of 1 and then the whole thing divided by 3. So it's going to be 1 point something. Oh, I'm sorry. Hold on. Okay, so if we try this 1 divided by 3, what's going to happen? It's going to be this. I to the power of 1 divided by 3. So let's try this. 1.04. And now, if we take out the parentheses, it's going to be the same thing. So by grammar, by the default, pi would take just 1 right here as the power. But we want 1/3 as the whole as a whole. So for this, we are supposed to put parentheses right here. And now we get pi to the power of 1/3 as we wanted. All right, now there is one thing we need to take a look. We got the value that we want, but it's assigned to this ands. We want it to be r, not ands. So in order to do that, we need to do this. So we have this value that we want, and then we want to assign this value to a variable r. So we can do this. R equal to this calculation. There is one thing I want to tell you is that when you have this equal sign inside MATLAB, it's not an equation. It's not like we solve an equation. It's the assignment of value. So what is happening here is that we calculate this. And once we get this value, we assign it. We give it to r at the end. Okay? So once we press enter, we are going to get a new variable r in the workspace, like this. And there you go. We have r stored in the workspace. So this is how we calculate something and give the value to a variable. Okay, so right now we have these two variables, and we can use it again. For example, I want to use r again. I can press 2 times r like this, and it becomes 2.8, 2.9 something, like that. Once you have it in your workspace, you can use it again anytime. Okay, but if I happens to clear everything like this, clear all, everything is gone. And if I type 2 times r, it's going to complain to you. I don't know r. Unrecognized function or the variable r. So every time you try to use a variable, make sure that you have it inside your workspace. So let's create r again. Now, we have it right here. But now, if you want to use it again without having to type again, so there's one thing we can do. We can press right here. We can press up. It's going to go back to the old command like this. The previous one is 2r, and I go one step further. It's clear all, and one step further. All right, not the one I want. Okay, one more. All right, and now it goes back to the old command, and I can use it right away. Okay, and now for the old command, there is one thing you can do. You can always check the command history. So the old one is right here. One thing you can do is to copy and paste like this. You can do that, or you can double click on that old command, and it's going to do that right away. So choose whichever way you want. Okay, so that is, we have R already. And now we are supposed to find the area with area of a circle with this radius. So area would be pi times r and squared. That's it for the calculation. And we can use r because we already have r in the workspace. Now, if I press enter right now, the result will get assigned to the default variable ands, like this. Ands show up like this. But maybe for some reason you want to keep this value for using later. Then you can assign this calculation to another variable, like maybe area. So with this, it's going to calculate and give the value to area. And area shows up in the workspace with the same value. And when you have it right here, you can use it again. Area plus 3, like that. So it's available to you. Okay, so yeah, so that's it for the number 3. So for this one, make sure that you know that you can assign the calculation to a variables. And once you have it in your workspace, you can always use it again. Now, when it comes to the command clear, the way that we did in the past, 2 minutes ago, we used clear all, clear everything. Now, what if you want to clear some of the variables? For example, I just want to clear ands only. I just put clear like this and clear ands. And this is going to erase ands only. The rest is the same. This is important because sometimes you have to manipulate your storage. You have to erase some of the variables, not the whole thing. So this is one way. Or you can click, right-click right here and delete. You can do that too. But it's not nice to use this kind of clicking because we have command to work with. So it's better to work with the command in the command window. Okay, but it's all up to you. Okay, so that is how you assign value to the variable. Now, I'm going to go on to the next part, which is the command for exponential, logarithm, and trigonometry, which means that you need to know the command for these functions. Okay, let's take a look at the lab sheet at this point. We have exponential. We have natural log right here. We have log of base 10, and we have log of base 2. So let's take a look at the command that we need for this one. So the first one is exp. This command is for e to the power of whatever that is. If you want to know the information of this, you type help exp, and you know this is exponential of whatever you want. Now, this you have to be careful because sometimes you see e and you use e to the power of like this 3 right away. And if you do this, you get an error because e from MATLAB is unknown. MATLAB doesn't know the variable e, so it's not 2.7 something. So do not use e to the power of x or anything. You always use exp. Okay. Now, let's take a look at next one. At this one, so we need exponential of 3. So let's have that right here. exp 3, like that. This is e to the power of 3. Now, let's take a look at the next one. Next one that we have right here, natural log of e to the power of 3. So when it comes to natural log, we use this command, log. So plus natural log inside MATLAB is log. Okay, for some of you, you might wonder why we use log here is ln, but it happens to be the command, the syntax in MATLAB. That log is natural log. I can prove to you that if you type help and log right here, it's going to explain to you that log command in MATLAB is natural log, not log base 10. So from now on, log in MATLAB is ln. Okay, something you have to keep in mind. So for this one, log is natural log. Now, what if you want log base 10? It's going to be log 10. Help and log 10. And it shows that log 10 command is logarithm of base 10. Okay. Now, what if we need log of base 2? Then we have another one. Help log 2. So this is log of base 2. Okay, so now that we know all of this, we can use them all to solve this one. And now we can go back to this. So let's put everything in. So let's start with the exponential of 3. exp 3. And let me check again. The next one is plus. And now natural log, but inside MATLAB, we use log right here instead of ln. And now inside this, we have exponential of 3. So we have to put exp 3 again so that it's inside ln. And now next one, minus log base 10. So for this one, we have to use log 10. And inside this function, we have exponential of 3 again. So well, I'm too lazy to type. So we copy this and put it right there. And now we get the top of the fraction. Now this whole thing has to be divided by, down here, we have log base 2. Okay, so we have division like this, and log base 2, log 2. And now inside we have 2 to the power of 5. So for this one, it's easy. We have seen before. 2 to the power of 5. And that's it. All right, that's not the end. So this is the calculation. And in the lab sheet, it says that the result has to be assigned to the variable y, a new one. So at this point, we know to assign to a new variable, just put y equal to. Okay. All right, and there you go. And you are supposed to get the same number as I did, 4.35. Okay. Now, at this point, I want to show one syntax to you. It can be helpful later. So at this point, I want to clear everything, clear all. Workspace cleaned, clear screen. Now, if I do this, the last calculation that we did, it's going to show this 4.35 on this screen. Now, let's take a look at this. What you see right here, this is called the output from the command. There is one way to suppress this output, right? So and that way is to use semicolon at the end. All right, I'm going to show you again. Clear everything, clear all, and clear screen. And now I'm going to use the same command, but with semicolon at the end. Now, after I press enter, it seems like nothing happens, but actually the calculation is done. And the assignment to the y variable is also done here. The only difference is the output at the end. This semicolon makes your screen cleaner. Sometimes you have many commands right after one another. And if you have output all the way through, it's going to be really messy. So with this semicolon at the end, it's going to suppress the output. Without this, it's going to show this extra lines right here. Okay, so if you want to keep your screen clean and you want to just get the value in the workspace, you can just put semicolon in. Okay, so that is number 4. All right, I'm going to continue with the next one. I know that it's we have lots of exercises, but each one is different and it uses different commands. So it's a good opportunity for you to learn about all these commands along the way. Okay, now let's take a look at the next one. All right, we are done with this. Now let's take a look at this one. This one is super easy. We have to solve this 3 to the power of x equal to 17 by using MATLAB. But before going into the MATLAB, we can work on this by using our hands. So we are going to take ln on both sides so that the x comes down. And now we can move things around so that we can find this x to be equal to ln of 17. All right, ln of this divided by ln of 3. So this is simple math. All right, I don't have to explain about that. Divided by ln of 3. And that's it. You can use this MATLAB along with your arithmetic, along with your handwriting to solve this one. Okay, so for this one, you can choose to show the output like this, or you can choose to suppress the output. The result in the workspace is the same. You get this 2.5789 as the answer for x. Okay. All right. So now, next one is trigonometry. And I need to tell you about the commands for the trigonometry, all of them. We have like 6 of them. So let's take a look. It might be boring at the beginning because we have to talk about the definition and the grammars, but it's going to be helpful to you later with the understanding of these things. So help, first one, sine, is sin. Okay. Cosine, help, cos, cos. And now for tan, help, and tan. And as you expected, the rest would be help. Secant is SEC, secant. And now for cosecant, cosec, it's going to be CSC, like that. And now last one is cotan, and that is cot. C-O-T, cot. And now what about the inverse of trigonometry? Like arcsine, arctan, arccosine, all you need to do is to put a in front of these commands. Like help, asine, I'm sorry. And you get arcsine. And of course, a cos, and for the rest is the same. Just put a at the front and it becomes the inverse, the arc versions of these functions. Okay, that's all you need to do, need to know. All right, now let's go back and take a look at the exercise that we have here. Okay, let's take a look at this one. We have sine of pi over 6. So let's put this inside MATLAB. What about everything all at once? Okay, you can put this in before me, and let's see if we have the same result at the end. So for this one, we have sine, and we have pi divided by 6. Okay. All right, and next one, we have 10 minus 10. Okay, for this one, we have 10 of pi over 2. I want to change this to pi over 4 because 10 90 degrees is undefined. So division by 0. So let's change this to pi over 4. Minus 10 pi over 4, like this. And now next one, sine pi over 6 square. Sine, okay, plus sine pi over 6. All right, this is sine of 30 degrees, but then we have square. But you look at the notation in your sheet, and then you put square right here, and then it's wrong, okay? in MATLAB, you cannot put square like this. Square has to be at the end of the function. So we have sine first, and then we group this together in a parenthesis like this, and then you can square this one. All right, do not follow directly from this notation. This notation square right here does not work in MATLAB. Square at the end in MATLAB. And now we do the same thing for cosine. Okay, for this one, I'm going to get lazy again. Plus, copy. Okay, and I just changed this to cosine. There you go. Now we get what we wanted. Sine square plus cosine square. Same angle. The result should be 0.5. Okay. Now, there is one thing that you have to be aware of when it comes to calculation in MATLAB, whether it's trigonometry or any function. Everything works in radian, always. When you use sine of something in MATLAB, it has to be in radian. For example, if you type pi right here, you get radian, 3.14. Now, what if the problem that you have here gives you degrees instead? Like this one, what if it says that it's 30 degrees? And this one, 45, and this is 30. Let's see what's going to happen if you put degrees in. Okay, so I'm going to repeat this and then change this pi over 6 to 30 degrees. And this one to 45. And this one to 30. And last one to 30. Okay, and now you press enter right away, and your answer is wrong. Because when it comes to all these functions, you have to put radian into the parentheses. So this 30 is not going to work here. It's going to see this 30 as 30 radian, not 30 degrees. So to overcome this change of units, you are supposed to change this 30 to be radian before you put in. So to change degrees to radian, you have to divide this degree by 180 and times pi. So if your problem has degree and you have to use MATLAB, you always have to change your degrees to radian. So this one, I'm cheating again. So divided by 180 times pi, divided by 180 times pi, and divided by 80 times pi. And now the result should be the same as before, 0.5. Maybe you should make a note. Inside MATLAB, everything has to be in radian. Okay? All right, so that is the exercise 6. And now let's take a look at the next one. Okay, so let's take a look at this one. I'm going to try to go slower at this point. All right, so we need to assign, all right, 32 pi to x. Okay, let's do that. But before that, I'm going to erase everything, clear all, and clear screen, CLC. Okay, this is easier to look at. And now assign 32 pi to x. 32 times pi to x. Assign it to x. And I don't want to see the output. I just want to assign it. So I want to suppress the output like this. I want to keep it clean. Okay. Seems like nothing happens over here, but actually in the background, we already assigned 32 pi to x right here. What else? Let's take a look. And now we need to solve this. Okay, y equal to cosine hyperbolic square of x and the rest. So let's put that in. So for the hyperbolic cosine and sine, well, for the command, you probably can guess it's going to be just cosh and sine h. So let's check it out. Help, cosh. Okay. And once again, it has to be in radian. And help, sine h. Once again, in radian. And now they want y. Let's give that to them. Y equal to cosh of, well, x, right? Now I can put x in because I already have x workspace. If I don't have it here, it's going to complain to me. But right now, it's OK. Oh, I'm sorry. Cosh right here. And the whole thing square. Like that. And now at the back, I'm not typing that again. So copy and go to the back. And with this one, it's going to be sine h, the same x. And this one, I can choose to suppress the output, or I can choose to display it. For this one, why don't we display it? And we get y equal to 0. And that is the result of this cosh square minus sine h square. OK. Are you guys still with me? Hello?
Is there?
Still, right? OK. If I
Yes.
go too fast, let me know. All right. And if I go too slow, too boring, let me know as well. OK. The thing is, I want to assume that you have basic programming understanding. So I want to keep it at the right pace. Too slow and it's too boring to you guys. OK, now next one. It's about complex numbers and phasors. And it's going to be related to the stuff we talked about in power system. OK, so let's take a look at this one. So we have complex number, and we also have phasor. Now, at this point, I suppose that you guys know that when it comes to complex number, real part and imaginary part like this, we can always construct the complex triangle. Real part like this, all right, at the base, imaginary part. And then with this two things, we can create this triangle, and the hypotenuse becomes the size of the phasor. This one right here, 10 is the hypotenuse, and 40 degrees is the angle that this hypotenuse makes to x-axis. So in the end, it's the same. This is complex, and this is also complex, but we choose to represent it in terms of phasor. But now we can operate between them. Now let's take a look at how it's done here. Okay. Now, when it comes to complex form is easy inside MATLAB. So let's take a look at the syntax and notation for complex. Okay, when it comes to complex, I'm going to use simple numbers, 3 plus 4i, like this. I can assign this to x. Okay, what about z? Z equal to 3 plus 4i. Okay, so there you go. But it's not just I. We can use j as well. So for electrical engineering, we usually use j for the complex. Like this, z equal to maybe 4 plus 5j. So I or j in MATLAB, interchangeable. And the reason that we electrical engineers do not like using j for complex is because I usually represents the current. So to prevent the confusion of the notation, we use j to represent the complex, the imaginary part. Okay, now you can use either one, but watch out for the location of I and j. Do not put j or I at the front like this. like here, we have J at the front, but if inside MATLAB you put it like this, it's going to complain to you. It's the grammar inside MATLAB that J has to follow at the end. So do not do this. You have to do that. Okay? And this is telling us that I and J by itself has a meaning inside MATLAB. So let's check it out. If I press I like this, it has its own value. We didn't assign square root of -1 to this I. It's default in MATLAB. And also J right here, square root of -1, default. And this is telling us that when you work inside MATLAB, do not create any variables with the name I and J. You can use X, Y, Z, W, anything, but not I and J because it has its own value already. So avoid using I and J inside MATLAB. That is not about complex. Okay, now, one thing I need to tell you when it comes to representing this 5J, you can use this as well. 5 times J, it's the same. 4 plus 5J. When it comes to this notation, multiply, you can put J at the front. J times 5, this is okay too. Same value. The only one that has problem is when you put it like this, J5, this doesn't work. Okay? So sometimes you can have like sine of pi divided by 3, like this, and then you want this to be imaginary. You can just multiply J in, and your value becomes imaginary. So you can just use a multiply sign. Okay, that's it that you need to know about the complex form. Now, what about phasor? Let's take a look at this one. So this one is tricky. This one, not straightforward. We have to do calculation along the way. So I want you to try to focus on this phasor because we might need to use it. You might need to use this one in power system too. So right now we know 10 is the hypotenuse, and 40 is the angle that it makes to x-axis. But in the end, it's still complex. So for this one, we know that the real part of this phasor is going to be the cosine component, right? So I'm going to take 10 and cosine 40, and that is going to be on x-axis, and that is the real part. Okay, so take this one as the phasor, and now I know that if I take this hypotenuse and I multiply cosine 40 like this is going to be the real part. If I want the imaginary part, it's going to be sine 40. But what I put in right here, this is wrong because inside MATLAB, we have to use radian, but I put degrees in. So in order to make this right, I have to divide by 180 like this, and then times pi. And now 40 becomes radian. So this is the real part of that phasor. Now, what about the imaginary part? We all know it's going to be this one again, but it's going to be the sine, all right? The real part is cosine, so this one is going to be sine. All right, and not just that. This one is supposed to be imaginary. So we are going to multiply J at the end. So there you go. This is the complex version of this phasor that you have here. Okay, so 10 with the angle of 40, if you change this to complex, it's going to be equal to this numbers. Okay, 10 cosine to 7 and 10 sine to 6.4. Okay, now there is another way to express phasor inside MATLAB. So let's take a look at this one. So we know that the size of the hypotenuse is 10. So why don't we put that in? All right, the size is 10. Okay, and now the angle of 40. If you can remember what I taught in power system, I told you guys that this angle right here is equivalent to e to the power of j angle, right? Angle of theta is equivalent to e to the power of j theta, which means that this is going to be equivalent to e to the power of j 40 degrees. And I'm going to use that inside MATLAB. Okay, times e to the power of, for this one, I have to use exponential. And now j times the angle, 40. But as I told you, inside MATLAB, you need to change everything to radian. So once again, divided by 180 and multiplies pi. And the result that we have right here supposed to be equal to this one we had before. And there you go. So for me, if I see phasor, I'm going to use this command because it's shorter. Otherwise, you have to repeat the same numbers with the cosine and sine and the imaginary part. Why don't we put it in this way? Size and the angle. Just change the angle to exponential of j something. Okay? So from now on, if you see something strange inside power system problems, you can always use MATLAB. You can use phasors here by using this command. Okay. All right. So there you go. And now we want to find this value. So let's put everything in. Okay. It's going to be long. So z, they want this whole value to be assigned to z. So z equal to, okay, first complex. I'm going to put 5 plus 10j. 5 plus 10j. And multiplies with another one. 5 plus 7j. 5 plus 7. This one I can use I. No problems. Okay. And divided by another complex. And that is 1 plus j2. 1 plus j2. If I put it this way, it's going to be a problem because j2 is not defined in MATLAB like that, j2. So if I want to keep it this way, one thing I can do is to put multiplies right here. And it's OK. Or you can put j at the back if you want. So that is the front fraction that we have right here. But now plus the phasor at the end. Plus the phasor at the end. And I'm going to copy the old one up here and put it right here. 10 with the angle of 40 degrees adjusted to radian with, 180 and pi right here. And, oh, what's going on? OK. There you go. And that is the answer for this one. So you can see that all those messy calculations in power systems, if you put those into MATLAB, it's just one line, and you don't have to put anything in your calculator. Okay, so yeah, sometimes if you do the homework in power systems, this might be useful for you guys. Okay, now let's move on to number 9 of the first section. This is the longest. This section 1 is the longest. The part after that is easier going. So let's take a look at the number 9. So take a look at this one. Okay, we want to assign this complex number 80 plus J60 to A. So let's do that. All right, and then find the phasor of A. Okay, so let's go back to MATLAB. And first thing, I'm going to clean this up. Too messy, right? And clear. I can clear all these variables one by one like this. And X, Y, if I do this, these variables will be set like that. But if I want to clear everything, just clear all. Okay, now A is supposed to take this value 80 plus J60 plus, I'm going to say 60J like this. So right now I'm going to suppress this and restore this value of A right here. Now, if you store that something in the workspace already, you can always double click to see it right here inside a table. Okay. And now if you don't want to see it anymore, you can just close it like that. Okay. Now we want to find the phasor of A. For this one, MATLAB is not going to give that to you, but we can do the calculation ourselves. So we know that when it comes to phasor, we need the hypotenuse. So we need the R. Hypotenuse would be equal to square root of real part square plus imaginary part square. 80 square plus 60 square. There you go. Oh, what about I don't suppress it? Let's display it. So we know hypotenuse would be 100. But we have another command to find this 100 without having to do the square root thing. So you have a complex number A, this one, and then you want to see the hypotenuse. So R can be equal to absolute of A, 100. So it's going to compute the same thing, absolute. To you, absolute might be just make everything positive. But when it comes to complex, it's going to find that hypotenuse, the length of that. Okay, can you hear me?
Yes.
Hello?
Yes,
So
yes.
how long have I been muted?
About 5 minutes or something.
Okay, all right, okay, that's good. I thought I have been muted for like half an hour. That would be a problem. Okay, so what is the last thing I talked when when the sound is still on? All right, I think maybe one of you muted me and I didn't know. So I want to make sure that the information I give to you right now is recorded. So can you tell me the last thing that I talked about that the sound was still good?
I believe you talk about like absolute value of complex number is its magnitude or something like that.
Okay. All right. What about I do problem 9 again really quickly? Okay.
Sure, sure.
Okay. Who muted me? I didn't know that. All right. Okay.
I thought you I thought you were
No,
on phones or
I didn't do
something.
that. I wasn't talking to anyone. Okay, if during at any moment and my sound is off, please let me know. Otherwise, it's recording nothing. Yeah. Okay. I'm gonna try to go slower. Let's try to finish this by in half an hour. It's not long from now. The longest part is the syntax and commands at the beginning. So CLC. And now let's clear everything. Clear all. Okay, so let's take a look at number 9, almost the last one, guys. Okay, so we have this complex number, and let's construct this inside MATLAB. We want this number 80 plus J60. Inside MATLAB, we have to use 60J, and now we assign it to A. Okay, and at this point, I want to suppress this. I just want to store it. And we have it right here. Okay, so it's stored and we can use it at any time. Now, at this point, we are supposed to find the phasor form of this complex number. Right now, we know 80 is on the real axis and 60 is on imaginary axis. Phasor would be the hypotenuse. Okay, so if we solve this directly, it would be the hypotenuse would be equal to square root of 80 square, Pythagoras, plus 60 square. Okay, and let's display it, 100. But when it comes to the command for finding this this hypotenuse, the size of complex number, we can also use this command. You want to know the size of A, we can use absolute A, like this. So it's the same hypotenuse. Maybe you guys are familiar with the absolute sign that you have been using. It's make everything positive, but this one is different. Absolute that you see right here is the size of the hypotenuse, the size of the complex number. Combine everything in. Okay, so not the same as absolute minus 2 equal to 2. Okay, that is different. All right, so we got the size or the hypotenuse. Now, what about the angle? At this point, we know 80, we know 60. We can use arctan to find the angle. So angle would be equal to a tan, 80, 60 imaginary divided by 80. And we can assign this value to theta. so that it takes the value of the angle. Now, at this point, you might ask me, aren't we supposed to use aren't we supposed to use the radian inside this? Because we used radian all the way along. But keep in mind, this is arctan. What you see right here is just the length of the sides, so don't have to worry about the radian and the degrees. But what you have to watch out is the result. The result right here is 0.64. This is the angle in radian. Now, if you want to know the angle in degrees, you have to calculate to find the degrees. So for this one, the result would be in radian. Now, to change it back to degree, you are supposed to divide pi and times 180. Okay, there you go. You get 37. Of course, 80, 60, angle is 37 and 53. So don't forget that the result from MATLAB is always radian. If you want the degree back, you have to calculate further like this. Change it back. Yeah. All right, so that is 9. Okay, let's take a look at 10 really quickly. So for 10, we have this phasor S. Okay, let's construct this one, S. So we know the hypotenuse and we know the angle. I'm going to rely on the formula that we had before. This one right here. Let's take a look at the command history. I'm going to copy this and put it right here. Paste. And now I'm going to adjust the size to this new one. Sorry. Which is 40 and the angle of 30. Okay. So 40 with the angle of 30, like that. And now I adjust it to radian with this calculation. And now we assign this to the variable big S. Okay, right here. There you go. So this phasor becomes complex inside MATLAB. And now we can see that for this one, we are supposed to extract the real part and imaginary part. So if you see this result already, you can extract it yourself. But what if you want to use MATLAB command to extract the real part? You can do this. So this P is supposed to be the real part of S. So command is real, and you put S in. And now the result would be 34, just the real part. And now, if you want to extract only the imaginary part, Q, you use the command imag, imaginary, imag. So it's 20. So that's it. As long as you know about these commands and syntax, you can do a lot of calculations related to engineering applications. It's more powerful than you think it is, but you have to be careful about the grammar inside all of this, all of these lines. Okay, and that's it for practice 1. Right now, I'm going to give you guys a 5 minutes break, and we continue with practice 2. And as I told you, this is recorded. So if you think this is a little bit too much for now, you can come back and watch this again later. Now, next one would be practice 2 in 5 minutes. Okay. In the meantime, I want to show you the assignment sections of this lab. This lab is like a lecture. I give you the information about the MATLAB, and you are supposed to own on some problems, and then you submit the work later. So let's take a look at the assignment. So it depends on how much time we have today. I don't want it to be too long because the lab is supposed to be done by itself. So I try to finish everything by 3 p.m. And the rest of the 1 hour, you can work on your own and you can spend extra time on that. So as of now, you should be able to start doing assignment part 1. So this one would be due next week on Tuesday. I give you guys 1 full week to work on these problems. Okay, so you can check this out later. Of course, you have to know about all those commands like exponential, trigonometry, the square or the square root, those kind of things. Complex, also important right here. So for this one, you have to work on your own. And now the next thing that we have to cover is about the vector operation. When it comes to MATLAB, sometimes we have to work on multiple dimensions. So this is the next thing we want to talk about. Really quickly, it's not that long. It's just about how to construct vectors and perform arithmetic on them. Okay, so about the assignment, one thing I want to show you is that when you submit the work, all you need to do is to capture the command you type on the command window. Whatever you type in and you get the result, you just capture that and paste in your file and send it to me and submit to me. You do not have to write everything all over again in the report. Okay, I just want to see what you did on your program. Okay, so do not waste too much time on the rewriting everything. Okay, so just work on MATLAB and capture the result and turn it in. Okay, so that is assignment part 1. And we also have part 2 down here. I'm going to talk about that later. Okay, at this point, I'm gonna have to chat with you guys. So all of the stuff that I just talked about, do you already know them?
I mean, pretty much, I think.
Pretty much everything, really?
I know quite a few of them.
The thing is, we have some details inside the each function. And in order to understand, yeah.
I don't think we like actually go over the the details of the function. Like I don't think we ever
Okay.
done that. But
All right.
we have
But
done like
isn't this the
Fourier.
first MATLAB course for all of you?
This is not the first MATLAB.
The first, not the
It's-
first?
Yeah.
Oh, really? Okay. So you took which lab did you take about this? Which lab?
It's
Second year?
signal and
Okay.
system.
Well, that's okay. You can think of
So,
this as some easy
Just
exercise.
think of this like we've done like Fourier transform thing in the
Okay.
MATLAB. So I think we should be pretty comfortable with this.
Okay. What about think of this as something to work on the basics, right?
Yeah.
Okay. So it's good. It should be easy for you guys to do the assignments. Because I don't know the background, whether you have done a lot or not. Because for in some years, some of you, some of the students do not know any syntax at all in the 3rd year. So this is what I taught last year. Well,
Yeah.
I should have asked you before, but
But it's fun though.
okay.
Because I talked to some of my friends. They thought like they need some like
Okay.
revision or something like that.
All right. Well, let's think of this as to strengthen your basic. All right.
Yeah. Sure.
Because it might be a while since you did this.
Yeah, it is a while.
Okay. Now, I'm gonna go over two things, and we are gonna call it we call it done today after two things, two topics. The first one is the vector operations. You guys need to know about that on some level, and some plotting really quickly. Okay. All right. For those of you who still have the energy to go on. All right, let's continue. This one is not as long, don't worry. Now that I know that you know a lot about this already, so I'm going to ask you questions along the way. Okay. Okay, let's take a look at practice 2. Let's try to finish this in probably 15 minutes. Okay, construct a row vector. This one. Okay, so I'm going to give you the command. Okay, row vector of x equal to 1, 2, 3, like this. And I'm going to suppress the output with the semicolon. And now I get the vector x right here. You can check inside the workspace. Now, my question to you, is there any other syntax to create this vector beside what I just used? Anything else?
Yeah, I can think of two.
You can think of two?
Yeah.
What is that?
So the first thing is doing the spacing one, like 1:1:3.
Okay, what about I change this to 4 and 5 for now?
So
All right,
one
another way
colon.
to make this row vector, all right, instead of the space, you can use a comma. This one works too. Same result. Okay, I'm going to take this out. Okay, and we have two more ways to create this. Can you think of that? Can you tell me? Okay, first one, just the blank like this. Second one with the comma like that. Now, next one, we use the command linspace. Okay, let's try this. X equal to linspace. This is going to create a row vector, and you have to specify the starting point, the end point, and the number of elements. Starting point is 1, end point is 5, and number of element is 5. Okay. This is useful when you want to create a vector of length 100. There is no way we are going to create that from this kind of command, right? We want to stick on some automatic function. Now we have another way. This is another expression to create row vector. All right, we want to start our vector at 1, and then we want to increase the element by a step of 1. And now we want to stop at 5, like that. This is another command to create a vector of some length, uniform vector. Okay, so if you put this 100, it's going to go on like that to 100. Okay, so at this point, you know all these commands, all these options. Okay, and in your homework, in your assignment, you need the third and the last one, either linspace or this one. You need that for your assignment. Otherwise, you have to type everything 1 to 100. Okay, now I'm going to clear everything for now and back to the basic. Okay, we talk about difficult stuff and then back to this 1, 2, 3. Okay, so this one is X. And now let's take a look at this one really quickly. we want a column vector y, 2, 1, 0. Okay, so let's go back and let's have this command. 2, 1, 0. If you put it like this, 2, 1, 0, it's going to be row vector. To make it column, what should I do? To make it a column vector. Someone? So for that, we can do this.
Semicolon.
Semicolon. Okay. Or you can start with row vector and then transpose it. Transpose with this single quote, this one, single quote. But without the transpose, it's going to stay row. Okay. And I think we have a command transpose. Let's check it out. Yeah, I can use that. So I can say that y equal to transpose of this row vector. And you get column vector. But if you transpose column vector, you get row vector back. Okay, so now last one. Okay, so z is supposed to be the transpose of y. So this one is straightforward. Z equal to y transpose. That's it. Next one. A equal to all of these things. 2 times x plus z. Now keep in mind, right now, x is row vector. X is row vector, and z is also row vector. So we are operating between two vectors. So A would be equal to 2 times x plus z. So x, so you can see that x plus z, it's going to be 333. And then with the 2, it becomes 666. All right, make sure that when you sum between two vectors, they have to be the same dimension. Do not put y in because y is column. Y is column and x is row. It's not going to go together. So when you perform vector operation, make sure that they match. Okay, now next one. Okay, now we are going to talk about a product between two vectors. Okay, and it turns out that when it comes to product between two vectors on MATLAB, we have two types of product. The first one is called element product. It's going to be the product at the same location. So let's take a look at this one, element product between x and z. So let's clear screen. X is 1, 2, 3, and z is 2, 1, 0. And now I'm going to perform element product, x times z. For element product, we are supposed to put dot right here. Okay, so what this product does is that it's going to find the product at the same location and keeps the vector form. So it's going to multiply 1 to 2 to be 2 and put it at the same place. 2 times 1 and then 3 times 0. And in the end, you get this vector. 1 times 2 equal to 2. 2 times 1, 2, and 3 times 0, 0. We call this element product. The product at a certain location and it stays at that location. Okay. Now, what if I take this dot out? Then this becomes vector operation, vector multiplication. If you can remember from math, vector operation between two vector dot product. One of them has to be row and the other has to be column. And then you can multiply them together, row times column, and sum them together. That is vector product, the second kind. And it's when we don't have the dot right here. So let's see what happens if we do this. It's going to complain to you because when it comes to vector product, you can't multiply these together. To multiply vector product, you need one of them to be column. For example, x times y, like that. So I'm going to show x again and y again. And now x times y, this is vector product, and it's equal to 4. So this row is going to get multiplied with this column, 1 to 2, plus 2 to 1, plus 3 to 0, and it becomes just one scalar. What you see right here, this is dot product between two vectors, row and column. Now, if you want your product to stay at the same place, at the same location, you have to use this dot multiply. This is the mistake that students do a lot because it's quite similar in terms of meaning. Okay, so this is product element by element, x, z. So if I find this, x divided by z, element by element, it's going to be, oh, I'm sorry, dot divide. The dot identifies that it's element by element. So we have 1 divided by 2, and you get 0.5. 2 divided by 1, you get 2. And 3 divided by 0, you get infinity. In your assignment, most of the things that you have to do is going to be element operation. So do not forget this dot, because we have to perform at the same location, not the dot product between two vectors. Okay, something you might need to take note on this one. Do not forget about this. So this dot star is element product. And if you go dot divide is element division. And if you want to have the power, right, element by element, it's going to be dot power. Let me show you again. CLC, this is x, this is z. And if I have this x to the power of z, element by element, so we are going to get 1 to the power of 2 right here. 2 to the power of 1 right here. And then the last location, 3 to the power of 0 right here, equal to 1. Okay, so 3 kinds of operations that you have to understand here. Multiply, division, the power, element by element. Okay, so that's it for this one. Okay, so for 5 and 6, we are supposed to construct a row vector from 0 to 50, which I show you already, and I can show you again really quickly. So from 0 to 50. Okay, so let's take a look at this. CLC and clear all. Now, one way to construct that vector is to do this 0, 1, 2, 3, 4, and if you have the strength, you can continue to 50, but I don't. So I'm going to avoid this option. All right, so it's going to continue to 50, but we cannot use this kind of notation. It's going to complain to you or not. All right, so that doesn't work. Nothing is assigned. So we have to find another way. The first way that I told you is this notation, x equal to starting from 0. And I want to increase the element inside the vector by a step of 1. And now I want to stop at 50. And there you go, in one line, starting from 0 to 50. 0 to 50. So we have 51 members in this vector. Okay, let's try one more. Linspace. Linspace. This one is a little bit different. So we specify the starting point 0, and then we specify the endpoint. You can see that the order is different from this command, so you have to watch out. This one is starting, step, and end. But this one, starting point, endpoint, and last one, not the step size, but the number of the elements inside your vector. For this one, we know that this vector has 51 members. So you put 51 in. Okay, so it goes from 0 to 50. Now, if you count the numbers wrong and you put in 50, it's going to come out wrong. It's going to come out with these decimals. So you have to watch out for the second one. So for me, I like to use this one better. I like to use this one because normally I know the step size. Sometimes I don't know how many members I have, but I usually know I want to step by 1 so that everything goes from, everything stays a whole number. All right, so if I recommend to you, use this one is better. It's better. But it's up to, it depends on the situation. All right, so that is something I want to mention about the constructing long vectors. Okay, last one. We have to construct a column vector with the length of 20 elements. Okay, this time we know the number of the members. And then all of the members have to be 1. Okay, right now it's not increasing. Everything has to be 1 for 20 of them. Oh, it has to be column. So let's do that. So what about I do this? Y, let's call it Y. It's going to be linspace. Okay. And I know that the starting point is 1. And since I want to keep it 1 all the way along, the endpoint is also 1. Stay at 1. And now the length of this vector is 20. So I'm going to put 20 in. And if I press enter like right here, it's going to be a row vector. Right. Because linspace gives you row vector. Now, if you want to make this column, then you just, I'm not sure if I can do this. Let's try. The single quote. Yes, I can. So there you go. I have a vector of 1 all the way along, and we have 20 members inside this vector. Okay. All right. So what about I'm going to give you one more command for this ones, vector of 1s. So another one is this command 1s. This command is going to give you a matrix of 1s. Everywhere is going to be 1. But you have to specify the number of rows and the number of columns. As you can see here, 20 elements here, we have 20 rows. So 20 right here. Hey, this matrix would have 20 rows. And then we only have 1 column. So there you go, 1 column at the end. And you get this same vector. So once you know the commands and the grammar, you sort of have options to play around in MATLAB. It's like a language. So yeah, and sometimes you might need to look around for other options. So it can give you some flexibility when you write the code. Okay, almost done, guys. Okay, now we are done with the vector operations. We can construct long vectors with one command. We can operate between them. And now you can do all these questions from question 1 to question 4. As I told you, you have time to do this for 1 week. And along the way, if you have any questions, please send it to me. Please send a message to me so that we can save some time, because some of the stuff is quite straightforward. If you know the answer, then you know what to. If you know the command, then you can just type it in. Otherwise, you have to dig it up, and you don't know what went wrong. Okay. All right. So last topic of today, and it should take about 10 minutes. It's about plotting. I think this is quite useful for you guys because sometimes we have to plot the graph. You know, we have the data, and sometimes we have to calculate something, and then we have to display it on a graph. And this is how it's done. So let's take a look. Give me about 10 minutes on this, or 15 minutes to be on the safe side. Okay, so we do practice 1 and 2 right here. 3 for 1 and 2, and we are done today. I added practice 4 because at the beginning, I don't know if we have enough time to go through all of this, but I think this is getting too long, right? So let's try to finish practice 3 and call it a day. Now, let's take a look at this one. We are going to work on practice 3 on a script, meaning that we are going to have a workspace that we can execute commands, many of commands all at once. This is called script or M file. So at this point, if you are still with me, let's take a look at this. So far, we put the command in line by line, and we execute it one by one. Sometimes we want to execute list of codes, maybe hundreds of lines. We cannot do it here. And in order to make that happen, we have to construct a script. And this is how we start right here. So new script, click on this. You are going to get a blank space. This is where you put all your commands in. And once you press run, it's going to execute all the way through from the top to the bottom. Now, at this point, I want you to save this script somewhere on your computer. Save. Right now, I'm going to keep it on desktop. And I'm going to create a new folder, especially for this one. New folder, I'm going to call it lab EE. Okay, something like that. And now, this one, what about I call it P3? Okay, practice 3, P3. You can name it other way you want, but I'm going to keep it P3. Okay, save. All right, and now we can put anything in. For example, let me show you. I can put clear all to clear all the workspace, and okay, clear all, and then I can do this. X equal to 2, suppress. Y equal to 3, suppress. And Z equal to X squared plus Y squared, like that. And now I want to run all of this at one click. All right, no need to work on this step by step. press run right here. Now, on the first try, you might see a window popping up. Okay. Let me try something. I don't want you to have a problem because I did it. We don't have that extra window showing up. Let me try to do this. Hold on. Okay, I'm going to save as. And for desktop, I'm going to create a new folder. And for this one, I'm going to name it something else, like temp. Okay, and now I'm going to save this same file in another place to show you what's going to happen with the different names. Save. Okay, now what about I come back to this and clear screen, clear all. Okay, now I am going to run this code that I have right here. There you go. This is the window you are supposed to get when you first create a folder. And when you see this, all you need to do is to add to path, meaning that MATLAB will be able to see that new folder that you created. So just add to path, and there you go. Everything is run in one click, and you get all the values, X, Y, and Z, all at once. Okay, this is called script or M file. And this is when we use to write programs. Otherwise, we have to write one line and press enter and another line and press enter. So this will be the way to go in the future when you come to when you write long codes. Okay, now we are going to plot. So let's take a look at the information we have here. All right, now they ask us to create an M file, which we did. And now we are supposed to plot this graph of these terms, right? And now with the range of minus pi and pi, this is telling us that on the x-axis, it's going to go from minus pi to pi. So we are supposed to plot this graph. So the first thing we are supposed to do is to create the x value on the x-axis. So it's going to go from minus pi to pi. Okay, so first step, I go back to the script, and this is gone. Now, x is going to be value from minus pi to pi, and it's supposed to be a long vector. So I can choose the step of 1 right here to pi. And now let's see what's going to happen if I keep the step size 1, just like we did before. And OK, suppress. And now we press run. OK, let's take a look at the x values. Now we can see that we only have like 7 points. And as you know, when plotting the graph, if you have points this far apart, the graph would be terrible. So this means that the step size we used here is too big, too large. So we want to increase the precision of our graph. We can go back and change the step size to be maybe 10 times smaller, 0.1. Starting from minus pi with the step size of 0.1, a little bit larger, all the way through pi. And now we get x value going from minus pi to pi with a decent size and decent precision. Should be enough. Okay, 63 points. Now that we got the x value, we can find the y value from this function, 10 sine minus sine 10. So let's do that. Go back to the script. And now y equal to 10 of sine x, like that. 10 of sine x. Even though x is a vector, you can put it in. It's okay. Minus sine 10. Sine of 10x, like that. Suppress. Okay. And at this point, I'm going to run. And then I get the x value and the y value showing up in the workspace. I have all the data points, and now I'm ready to plot. Okay. Now, if you don't know how to use plot, you can always come back here and help plot. And you have all this information to read through. But for now, let's go with the flow. Okay, go back to the script and then plot. In order to plot, you have to put x value in and the corresponding y value. Okay, so, right. Okay, let me check. So it's 10 sine minus sine 10. So 10 sine minus sine 10. And now one press, everything executed all at once. All right, so we have a graph of 63 points based on the vector that we created here. You can make this vector x more precise. You can put 0.01 in, but as you know, when you go for precision, you are going to need more memory. You have more points. You need more calculations. It requires more computational power for that. So it's a trade-off. It's up to you. Now, let's take a look at the graph and the script right here. Okay, now at this point, let's say that, hey, we are not happy with this graph. We want to add information to this graph. And now the first command that we are going to use here is title. Title is going to put something at the top, title. Okay, and inside we put a single quote like this and practice 3. And now run again. And there you go. You have the title at the top without having to go through the menus. Okay, now the next thing is labels on the axis. I want to know what this axis is and what this vertical axis is. So to do that, you put X label. And now I want to say that on the horizontal axis, this is X. Okay, and on the vertical axis, Y label, this is Y. And now run. And you get this X and Y right here. Okay, now next thing, graph looking like this is not nice because we don't have the scales. So one way to add the scales or the grid is to go back here and grid on. And you have the grid. Okay. Now, here comes the options that you can put in to change your graph to look in a different ways. So let's take a look at the lab sheet right here. So we have all these options. So let's put this in one by one. All right, so that you see what's going on here. All right, starting with this. So we go back to the plot. The options that we want to add in is going to follow with after Y. Okay, so the sign that you see right here, slash hyphen, double hyphen, this is going, I'm sorry, this is going to make our line dotted and flat. Like that. Okay, And if you put R right here, it means red. Okay. And if you can check the code inside the help. So if you want it to be blue, you put B and then it's blue. Or G, it's green. Yeah, I know this is silly stuff, but it's good to know. And go back, K is black. Okay, now back to R. That's it. Making the line red and dotted flat. And now next one, S right here. It's making the graph to have marker, which means that at every point that we have here, it's going to have a dot, a marker. So let's see what happens. So all 63 points that we have in the data is going to have the markers. Before, it's just the line connecting them all, but now we have the marker for each one of them. So that is the meaning of this S right here, square for the marker. And now let's take a look at the next option. Let's put them all in. Line width equal to 2. Okay. Line width, and we want the value of 2, like that. It's going to make our line bigger, like that. Every one of them bigger. And now, next one, marker edge color. It's like I'm teaching Photoshop right now, but yeah, just go through with this. Oh no. Okay, marker edge color, okay. And for this one, this is one reason why I hate the new versions. It do the auto corrections with my code. Yeah. So marker edge color is supposed to be K, so that is black. So K right here, and the square would be black after this. Okay. And now next one, marker face color, the inside of the square. Now we want it to be G, and that is green. Okay, marker face color, and after that we have G. And you can see that the inside of the square would be green. Okay, now last one. The marker size is supposed to be changed to 10, so make it bigger. I am not sure about the default value, but I guess it's going to make it bigger. So last one, last option. So marker size, now the value is 10. Let's see if it's bigger or smaller. There you go. So all the 63 points of data that we have, they all have markers. And of course, we have the lines connecting them together, the red one. So that is how you plot. And if you know all of this, then you can plot just about anything. Okay, because that's all we need to know. That's all we need in a graph. The graph itself, the colors, the information, this is quite enough. Okay, last one, I promise. Let's do this really quickly, okay? So let's take a look at this one. So we are supposed to plot 3 graphs inside one figure. Last one, we only have 1 graph. This one, we have 3 graphs. And let's take a look at the range of x. X going from -3 to 3. Okay, and the first function that we are supposed to plot is y1 right here, a parabola, x squared plus 5, and solid black. So let's give that to them. And now next one, y2, x cubed And last one, x to the fourth. Okay, let's include all of this in the same fashion that we did before. All right, so I'm going to rely on the the old script. Let's erase this one and this one and this one. And now we hide the labels and the grid on. And this one, 3.2. Okay. And now x, it's going to go from -3 to 3. So it's going to start from -3. And I need to specify the step size. I can put 0.1 right here, just the same, or I can go smaller, making my graph looking better. I can do that too. Or 0.05, up to you. Okay. Now, ends at 3. And now the first function, y1, x squared plus 5. So this is going to be x squared plus 5. And oh, by the way, if you have some codes that you want to just comment to make it disappear without erasing it, you can do this and right click and put comment. So with this % sign at the front, we only have the text here. The script doesn't count these lines as the commands. So it becomes comments. You can say anything, hello, like this. It's just text. But once you want these lines to be the actual commands, you can take this out. There you go. Once it changed to normal color, it becomes command. Okay, so if I put this right now, it becomes comment. Doesn't mean anything. Now, let's take a look at this one. So if I stop right here and I execute this script, you are going to see an error. Let's run this. There you go. We have an error. So we created x just fine, but it complains about y1. Okay. And the reason for this complaint is because we put the square right here without the dot. What we are doing right here is that we square the x value element by element. So you are supposed to have dot right here so that each x becomes square at the same location. Okay. Now, next one. Okay. All right, let's compare to the lab sheet. Y2. Okay, Y2, and we have x cubed. All right, plus 5, just the same. And now last one, Y3, x to the fourth, like that, plus 5. And we have all the values. Let's try to run it. Okay, no sound, which means that everything executes smoothly. So we got, okay, so we got all the values right here, x, y1, y2, y3. And now we are ready to plot them all in the same figure. So let's go back to this. Okay, this, you can close this one. Now, in order to plot all three at once, you have to do this. So plot. So you are supposed to put x and y in, x and y1. This is going to plot the first function. And now if you want another function, you just put the pair in again. X together with y2, like that. Do not put it this way. They have to go in pairs, x and y, x and y. So for y2 to go in, you are supposed to have x right here. And last one, last pair, X and Y3. And we press run. Okay, so we have all these lines. Blue, I guess, is the parabola. The orange would be the power of 3, and the yellow would be the power of 4. Right now, the color is assigned automatically, so we didn't do it by ourselves. So we can change it later. At this point, I'm going to take the comment out. And now if I run again, I'm going to get all these information on the graph. Okay. All right, now a few things we need to take care of. So we want the parabola to be solid black. So I'm going to go in right here. You want it to be solid black. I'm going to add option right after Y1, right here. You want it to be solid black. Okay, that's it. And now let's take a look. Run again, and we get the solid black. So if you want to add any option to any graph, just put it right after the Y value of that function. Okay, next one. Star dotted blue. So this one right here, second function. Well, I don't know, they want it to be blue. So yeah, let's do that. Blue, and they want it to be star. Okay, let's try that. Okay, let's add this line. Okay, I know what's going on. We have too many points, so the stars are too close together. So it becomes this one right here. So if you zoom in, they are all stars. Okay, so in order to see the stars, I'm going to reduce the precision to 0.1, like that. And now run again. And there you go. Dotted stars. And now last one. Now we'll do what they want. So last one, flat dotted red. So last option goes in right here in the script. Okay, it's supposed to be red and flat dotted. We used this before. So, okay, there you go. We got everything they want. Okay, so this is just to play around. Okay, and last one, last command of today, and that is called legends. I think it's legend. Okay, legend. This command is going to put the information, the name tag on each line. Okay, so we have 3 lines here, and maybe we want to know the information for each line. So we have 3 of them. And the first one right here would be the information of the first function, y1, the parabola. I can put parabola in. Okay, next one, the power of 3. I can put power of 3. Last one, power of 4. So it's like the name tag to show on the lines. So let's see what happens with this command. Okay, so let's run. There you go. So with the legend, you can display to whoever is watching this that the black one is the parabola, not parabole. Sorry, parabola. Okay, black is the parabola. The stars is the power of 3, and the last one is the red, the power of 4. Okay, and after this, you are going to be able to do assignment number 2. This one right here, it's plotting. and it can be done in, I think, in 5 minutes. All right. So I think we spent quite a long time on this session already. So I'm going to stop at practice 3. I'm not going to go to practice 4. We can talk about this later, but not today. So for you guys, the assignments are this one, assignment part 1, all the calculations, and assignment part 2, right here, the plotting, which is quite easy if you know all the syntax and commands. Okay, so that's about it for for today's I'm gonna say session, lab session. But in fact, this is about me telling you guys about how to use MATLAB in general. The interface, the commands, and the script. So I hope that you can make use of this in other courses. And what about you try apply what you learned today to the homework that we have for this lab? And once again, I'm going to assign this on Power System Teams, so you can submit your file on this team. All right, guys, I'm sorry for the long session. At this point, do you have any questions about today's lab? If you are still here. Hello?
Hello.
Hello.
Okay, good to hear you. All right, so that's it for today. If you don't have any questions, you can start working on these assignments. Maybe you can get it done by in 1 or 2 hours if you know what's going on here. Is that okay? Hello?
Yes, of course.
Okay, so
Yeah,
that's it for today. Thank you for joining us.
I heard
Unless
that we have to
you
do
want to
the-
stay and chat.
I
You
heard
were
we have
saying
to
something.
do. I heard you told me like we have to do this like Simulink or something. Do we have to do that as well?
Do what?
Simulink. I think I heard someone said that. Like
Simulink? No,
yeah.
we don't use that. Simulink is like the add-on extension of MATLAB. We don't use that today. Today is all about the basic of MATLAB. So don't worry about Simulink. Or you can call it Simulink. Yeah, don't worry about that. Okay.
Okay.
All right, you want to stay and discuss some other stuff? Well, by the way, I'm sorry about yesterday. I have an emergency. I had to travel to a hospital, so I couldn't be there yesterday. But I'm going to have a makeup class, and I'll do it online so that I don't have to force you to come to the campus. All right. But for the time of the makeup class, we can discuss about that later so that we can find the right time for everyone.
So we discussed it in the next Monday, I suppose, that what we said last time. Was it?
Yeah, we can talk about the time of the makeup class next week.
So we have a class on Monday, yes?
Next Monday?
Yeah, do we?
Yeah.
Right, okay.
It's not a holiday, right?
It's not a
it's
holiday,
not
yeah.
the holiday. The holiday is on the
Holiday is on
Tuesday.
Friday.
No, it's on
Friday
Wednesday
and it's on Wednesday.
Tuesday. And Tuesday as well, I believe.
Yeah, the holiday is on Friday and Tuesday. So there's a class where some professors.
It's like our class is in between holidays, right?
Yeah, and that's
Yeah.
why some of the professor decided to have a holiday as well, as like a long holiday, like from Friday to Tuesday. But that's just some of the professor.
So right now you are indirectly pressuring me to
No, I'm not indirectly pressuring
no,
you.
I'm just kidding. I'm
asking
just kidding.
to make sure, because the class after you,
Okay,
the
let me
professor
ask
said
you.
to.
Okay, let me ask you. Next Monday, besides my class, do you have other classes, like in the morning and in the evening?
I actually have a class from
ตัดเหรี
8
ยญไว้
a.m. until
Yeah.
like 6 p.m. But the one after your class don't have a class. But for the class in the morning, I asked him, the professor, I mean, but he doesn't answer me. So I take it that I have a class in the morning too.
Okay, so for you guys, in the morning you may have a class, but in the evening no class, right?
Just me and some of the people, but not for Panavit and Pakon.
Okay. What if we make next week class to be online? How is that?
I am fine with whatever you say, sir. I'm just asking just to confirmation, like do I
Okay,
need to
let
be
me think
on
about
site
it.
stuff?
Because I know it's in between holidays and some of the classes are canceled. Okay, all right, let me think about it. But based on the schedule, we actually have class on Monday. So can you update on me about the class in the morning, whether
Yes,
you
sir.
have it or not? And if in the
If
morning
he
you
ever
don't have
reply me
class,
back, yes, I will tell you.
if in the morning you don't have class and in the evening you don't have class, I don't want to drag you guys to the campus just for my class because we have other options like doing this. Okay, so can you let me know later about the morning class on next Monday?
Yes, sir. If the professors will reply me back.
Okay,
If he will reply me
what
back,
about
then.
other people? Do you guys have class in the morning?
So the class in the morning is probability and stat. Some people take it last year, and most of the people from Power take it this year. So there's only like a few, like 3 people who don't have a probability and stat class, so they're accepted. But for the people who have a class, I tried to ask the professor because I'm taking that as well, and the professor didn't say a word about it. So
Maybe he didn't want to answer.
I don't know, sir. I just straight up
Yeah,
asked
maybe.
him, "Do we have a class next week, sir? Because there's a class in the evening. Say that he want to take it as a long holiday, no class. So I need to make sure that do we have a class,
Okay,
just to prepare to come to the campus.
What about for other people? Do you guys have class in the evening?
All of us don't have a
Panawit?
class, sir.
Panawit, do you have class in the evening?
I I have the same class as him, so
Oh, what about Pagon
Yeah.
and Win Yushon?
Yeah, they're all in the same class as me, sir.
In the same class?
Yeah, we're all in the same class, except for the one in the morning.
Okay, so in the evening, no class for sure, right?
For sure, yes, sir.
Okay, so the thing is, I missed the class yesterday, so I don't want to skip another one. So next week, what about I make it online, and it's gonna be recorded, which means
I'm
that
fine with whatever you say, sir.
Yeah.
Actually.
I just want the best options for everyone. So if you are okay with online classes next week, we can do this, and it's gonna be recorded, which means that you can come back if maybe you are on holiday or whatever that is, you can come back and watch it later. How does that sound?
It's
Next
good for
week
me, sir.
becomes online. Which one do you prefer? On-site or online next week? But I don't think I can cancel next week. So I can get your votes right here. Next week, on-site or online? Some opinions?
I gotta ask for the other guys because I'm actually fine for both of it.
Now, what about you guys discuss with each other, and then you tell me.
I think we could just ask people in this meeting right here because most of them are not going to have much opinion anyway. So what about
All
it,
right,
guys?
okay, so they want to stay silent.
I
Okay.
mean, yeah.
Now, what about here? What about here? Do you want it to be online or on-site next week? But no cancellation next week.
Personally,
Just want to
Personally,
hear
I
your
prefer it
opinion.
to be on site, but I'm fine with either options.
Okay.
I'm fine with other option. I mean, I have to come in the first class anyway because I'm not sure if we have a class or not. So I would just stay.
Okay,
You know.
what about right now? I'm going to just stick with on-site, just the way it is. But
Sure.
if you have, if you change your mind, let me know. Okay.
All right. Yes, sir.
Okay. For now, next week it's on-site. Okay. I'm gonna try to make it as compact as I can. Okay.
All right, sir. Thank you.
All right. Well, thanks for joining today and have a good evening.
I was eating when the class began. I wasn't
And-
even at my
And are you
room.
still eating still?
No, no, no.
Okay. All right.
That
Okay,
would
you
be
can-
concerning, you know.
You can
If I was still
you
eating.
can continue your eating right now. Okay. And I can do that too.
Nice.
All right, guys. Thank you for joining. I'll see you later next week.
See you.
All right. Thank
Okay,
you.
bye.
Bye.
Have a nice evening.
Thanks. You too.